Okay, we have some operations with fractions in our notes today, and we're going to be reviewing adding and subtracting fractions, multiplying or dividing, actually both, and then we want to make sure that anytime we finish a fraction problem, we reduce it completely. So this is definitely a review of stuff that you've done with fractions before, and it's always a good idea to review fractions because we know that they are all throughout mathematics, not just in algebra, but any mathematics that you study. And we want to have a basic understanding about how to simplify those expressions that contain fractions. So let's start off with adding and subtracting. There's some special rules that we want to remember about adding and subtracting fractions. You have to get a common denominator. So that's just a number. It's actually the smallest number that both denominators evenly divide into. So we're looking for a number. It could be one of the numbers themselves, but both numbers have to be able to divide into it evenly. We also will remember then that we have to multiply each numerator to enlarge the numerator to match how many times larger its denominator has become. That may not make sense right now, but it's one of those steps that you're familiar with doing. And then the third step is to add and subtract only the numerators and keep that denominator, that common denominator that you had already chosen. So let's go ahead and simplify these two problems. We have an addition problem, and when we have addition, we have to find a common denominator. So I'm going to pick 21 because when I multiply 3 times 7, those numbers multiply to 21. And that's going to be a number that both 3 divides into evenly and 7 divides into evenly. So how many times larger is 21 than 3? Well, that's 7. So now I have to take 2 and multiply it by 7. So 2/3 has become 14 over 21. And 7, this 7 here, multiplies times 3 to get to 21. So now I have to take my 4, multiply that by 3, and I end up with 12 over 21. So I've changed the two original fractions to two larger. They're not actually larger, it's just looking like they're larger. And now I'm going to go ahead and add just the numerators. And when I do that, I get 26, and keep that denominator as 21. Now, this is called an improper fraction. Improper are the type of fractions where the number on the top, the numerator, is larger than the denominator. So you can also spend the time to change that into a mixed fraction. And a mixed fraction would be where we take the denominator and divide it into the numerator. How many times does 21 go into 26? Well, just one time, but then how many are left over? The remainder is 5, and that goes on the top. So this is what we call a mixed fraction. Okay, so you'll want to, sometimes the directions will state whether you should leave it in improper form or change it to a mixed fraction. All right, let's go ahead and do the next problem, simplifying 2/6 plus 4/3. Again, we have two numbers that are not the same on the bottom, so we're going to need to find a common denominator of these two numbers. And I know that 6 goes into 6 and 3 goes into 6, so this is a little bit less work for us because we really only have to change the one fraction. So I'm going to keep 2/6 because that 6 is good for me there, but I do need to alter the second fraction because 3 goes into 6 how many times? That's 2, and 8 times 2 is going to be 8. Or sorry, 4 times 2 is going to be 8. And now I'm going to add across the top. That's 10. And we can reduce this and leave it in improper form, and if we reduced it we would get 5/3. And then if we want to make it into a mixed fraction, we would say how many times does 3 go into 5? That's just 1. And then we have 2 left over. So our final answer is going to be 1 2/3. Or you could leave it in the improper form, which is 5/3. Alright, the next type of problem that we have is going to be multiplying fractions. This one is super easy. We know that we can just multiply across the top and multiply across the bottom and then simplify if we can. So again, multiplying across the top, 2 times 4 ends up being 8, and 3 times 7, 21. There's nothing that we can do with this. This is an even number. This is an odd number. Those numbers don't have anything in common, so we cannot reduce it any further. Now when we're simplifying this next one, we notice that we have a negative symbol here, and we only have one negative between the two fractions, so that means that this is going to be a negative result when we get done, because a negative times a positive results in negative. So I'm going to have an 8 on the top, and I'm going to have an 18 on the bottom. Now remember, it's a negative result, but I do want to reduce this because I can see that 8 is an even number, 18 is an even number, so I can reduce that by dividing both of those by 2. So my final answer is going to be 4 over 9, because 8 divided by 2 is 4, and 18 divided by 9, 18 divided by 2 is 9 as well. So final answer, -4/9. Always reduce your fractions with any answer, any problem. Division, if you read this phrase here, it's just a kind of a rhyme. Dividing fractions, don't ask why, flip the bottom fraction and multiply. Okay, if it's not a bottom fraction, it could be the second fraction and multiply. So to rewrite this problem, notice that it's a division problem. I'm going to go ahead and rewrite it. I have a -2/3, and it says to flip the second fraction. So flip just means take the reciprocal. So now I have 7 over 4 instead of 4 over 7. I'm going to multiply across, and I do have one negative symbol there when I'm multiplying. I'm going to keep the negative, and I multiplied across. Oh my goodness. 3 times 4 is not 7. 3 times 4 is 12. So now I can reduce. That's just going to be reduced to -7/6. I'm just going to leave it in that form for now. The last problem here in the box, I have a -4 on the bottom, but if you recall, any whole number has a 1 underneath it. So if you see something in this form, remember that you can add that 1 under there. It doesn't change the number at all. It's allowing you to now flip that whole number, and when you multiply, it's going to become -1/4 that you're multiplying by. Notice that we have a negative symbol there. And if you multiply across the top, you end up with -3, and the bottom is 20. And those numbers cannot be reduced, so that's our final answer there. Try to find a way to indicate your final answer, whether it's putting a box around it, circling it, something like that, so that I can see what is your final answer. Alright, so there's some example problems down here. I'm going to go ahead and do C for you, just to practice another one of the ones that have the addition and subtraction. Remember, we have to find a common denominator, because this is one that is an addition, not addition, but subtraction. We need common denominator. So 5 and 3 have 15 that they both can go into. Alright, we have a negative symbol here, and we also have one here. So 3 times 5 is, 5 goes into 15 3 times, so I'm going to multiply the -3 by the 3. Okay, and then 3 goes into 15 5 times, so 5 times 1 is 5. So this could be rewritten, just so you can think about how to treat that negative sign. This could be rewritten plus -5 over 15. So my final answer here is going to be, when I add across the top, -14 over 15. Okay, after I find that common denominator and change the numerators accordingly. Okay, go ahead and change to the back side of your paper. We have a few more problems that I'd like to go over on this side. Specifically, I would like to go over G, L, and then the number 2 down at the bottom of the page. So this is just going to give us a few more practice problems here. Be careful when you're looking at each one of these problems. Notice that this one has a plus sign. That means that I need to get a common denominator first. all of these that have a plus sign. So just really be careful about, figuring out whether you do have to have a common denominator or not. Addition and subtraction, those are the problems that you have to find that common denominator. So if I'm looking at my denominators here, I have a 4 and I have a 6. Well, what number can I use that both 4 and 6 go into evenly? And that's going to be 12. 4 goes into 12 3 times, right? And 6 goes into 12 2 times. All right, so I can say, well, I'm going to use 12. I do know that I'm going to be adding, and I have a negative symbol here, and I have a negative symbol here, so I want to make sure that I bring those down as well. Okay, so if 4 times 3 was 12, then negative 2 times 3 is negative 6, and 6 times 2 is 12, so therefore I have to multiply this 2 by 2 also. And I end up with this result. Now I have to add across the top, so I have negative 10 over 12, and this can definitely be reduced because both of those are even numbers, and we can reduce it so that we end up with negative 5/6. Next up is this problem L. It's a division problem, so we don't need a common denominator, but we do need to do some work to get it set up properly because the second fraction needs to be flipped, right? We want to take the reciprocal of that second fraction. So I did that, and if I multiply across the top, oops, I didn't flip that at all, did I? Okay, so I'm going to end up doing this here. If I multiply across the top, I end up with 102 over 9. So in order to make this a little bit easier to understand, I'm going to divide 9 into 102. Well, 9 goes into 102 11 times, and there are 3 left over after that. So I have a 3 over 9. And I can reduce 3 over 9, can't I? That just reduces down to 1/3. Okay, so I have 11 and 1/3 as my final answer. Okay, finally I'm going to do number 2 here. This is a multiplication problem, so we're just going to multiply across the top and multiply across the bottom. And unfortunately, this fraction cannot be reduced at all. If you look at 33, 3 and 11 are the only two factors that we have that we could possibly use to reduce that. But unfortunately, 3 does not go into 256 evenly, nor does 11 go into 256 evenly, so we're just going to have to leave it in this form here. If you've come across any questions during this video, please make sure you ask questions, and you should be finishing up this page of all of these problems. You are allowed to use a calculator, but just remember all the rules. Adding and subtracting, we have to have a common denominator.